You guys have any questions? Yeah, I will pause your place over the weekend. So we also have a quiz breakfast. Okay, so we are going to look at section 3.3. I think this one is the last section of chapter. Also, you should know that we have an exam for that. Next Friday. So we have our exam on Friday at the same time. I was still right. So it will actually cover chapter 1 to, is it this Friday? I'm not so sure. I need to check. Not this Friday, it's next Friday. Yeah, it's actually next Friday, which is the week of 20th to 24th. So we'll have our first exam. And it will just cover chapter 2, 3, and 4. And we'll do chapter 4 next week. Okay, so today we are only going to do the section 3.3, and this is more of the application part of it. And we'll just do some of the examples here. And then after that, I'll give you a quiz, and you can just do in class. Section 3.3b. Section 3.3b. So actually, it will be more of perpendicular and parallel lines. The perpendicular and parallel lines. Are you able to see that? Okay, so example 1. Find the equation of a line perpendicular to y equals x minus 3 that contains the point -2 and 1. Find the equation of the line perpendicular to that contains points. So what do you do from there? So you know, if it is perpendicular, then you need to get the what? The gradient, right? Yeah. So you have the point, so solution. So we have our point, which is x1, y1, and this point is what? -2 and 1, right? So we can choose a point, which is what? xy. We choose the point xy. Now, we have our first equation, which is x equals to x minus 3. And we are told this is what? Perpendicular. So what did we say about our perpendicular lines? So for the perpendicular, M1, M2 equals what? -1. So we have our first M1 here equals to what? 1, right? Now, the other line, which is perpendicular to this line, will be having a gradient of what? So M1, which we know, which is 1, right? Equals to what? -1. So that means the gradient of the other line would be what? -1. -1. So the gradient of the other line will be -1. So now, to write the equation of this line, we know that we're using the point what? So slope 4. And it said y equals to what? Y equals to what? M x minus x1 plus what? Plus y1, right? If we still remember that, right? Plus y1 times this. Okay? Do we still remember this? Mm-hmm. Yes. So we have the points, these ones. So we now slot in. So we have our gradient there. So our equation will now be -1 there. X minus what? X1 is what? -2. So -2. And then plus y1 is what? Is 1. Y1 is 1. So finally, you can open the brackets. So y equals to -1, x plus 2 plus what? Plus 1. In Newton, you can write it like this, but when you can just open the brackets, y equals to -x minus 2 plus 1, which is now -x minus what? -1. So this is the equation of the other line.
So is it okay if you just leave it at the -1 brackets?
So it is okay if you leave it here.
Okay.
And it's also okay if you continue.
Continues going
Yeah.
down on it.
Yeah. So that is the equation of the other line. So make sure you know the difference between the perpendicular and the parallel. So another example. Find the equation of the line parallel to x equals -5 that contains the point 3 minus 2. Find the equation of the line parallel to x equals minus 5 that contains the 3. Without solving that, what is the equation of that? Without solving, what is the equation of the line which is parallel to that?
X equals 3.
Yes, x equals 3. We don't even solve the equation which is parallel. X equals to minus 5, right? So it is vertical line. So the other one which is parallel is what? We have the point is x equals to 2 equals to 3. X equals to 3. So we can say solution. The line x equals to minus 5 is a vertical line, and so a line parallel to it will also be what? Be vertical. And the line parallel to it is also vertical. And in this case, so the vertical line passing through the point 3 minus 2 is x equals to 3. Is x. Any question after that? All right. Another example. Find the equation of a line perpendicular to x equals to minus 5 that contains the point 3 minus 2. 3 minus 2. So what is the equation of the line perpendicular? Without even solving, what is the equation of the line perpendicular? Y equals what? So we say the x and the y are always what? So if one of the line is x equals to minus 5, so the line which is perpendicular, if you have given the point, is what? The one which has x, y equals to minus 2, y equals to minus 2. So solution. The line x equals to minus 5 is a vertical line. And so a line perpendicular to it will be horizontal. So horizontal line passing through 3 and minus 2 is y equals to minus. It's y equals to minus. Any question? Okay. Another example. Find the equation of a line parallel to 5x minus 4y equals to minus 3 that contains the point 5 and 3. Find the equation of the line. Of the line parallel to that contains a point 5. So we have the point x1, and solution. So our equation is 5x minus 4y equals to minus 3. So we need to write this in the form y equals mx plus what? Plus c. Or plus b. So in this case, we need to take the values of x to the other side. So minus 4y equals to minus 5x minus what? Minus 3. So when you take 5 to the other side, you get minus 5x. Then you do what? You divide by negative 4. So our y equals to negative 5x all over negative 4 minus 3 all over negative 4. And finally, this is 5 all over 4x plus 3 all over 4. So that is our equation. Now, here, our gradient is m equals to what? 5 over 4. We said if it is parallel, they have the same one. They have the same. We said the first one, they can be having the same one. Gradient and different intercepts. Y-intercepts, right? And different intercepts. So here, since they're parallel, then we need to, so the value of m is the same. So we have our x1 plus y1 here. So using the point intercept form, so our x1, y1 is what? 5 and what? And 3. So using our point intercept form, we say y equals to m x minus x1 plus what? Plus y1. So we just substitute here. So y equals 5 all over 4. X minus x1 is what? Minus 5 plus y1 is 3. You can just leave it like that. You can just leave it like that. Or you continue. So our y equals to 5 over 4x minus 25 over 4 plus 1 plus 3. If you continue there, then it will be 5 over 4x plus 1. So LCM is 4, 25 minus 25 plus 12. What do you get?
13.
So you get minus 13 over 4. Minus 13 all over 4. Any question? If there is no question, then the next example. Now, the same thing, find equation of line perpendicular to 5x minus 4y equals to minus 3 that contains the point 5 and 3. Now, if it is perpendicular, I can change that one to perpendicular. So what will happen? So if we change it to perpendicular, so that means for perpendicular, M1, M2 equals to what? -1. We already got the M1 as what? What did we get as M1? 5/4, right? 5/4. Now our M2 will be M1, which is 5/4 times M2 equals to -1. Equals to -1. So we know M1 is 5/4. We need to look for, yes?
So how do you get the first grade? The Bible?
Yeah. So this is actually similar to the previous. Yeah, that's a 5. So 5x minus 4y equals to -3. So we take this one to the other side. So minus 4y equals to -3 minus 5x. So if you divide both sides by 4, -4, you get y equals to 5/4x plus 3/4, right? That's what you got previously. So we know our M1 is equals to 5/4. Since this one is perpendicular, then we use this M1, M2 is what? Is equals to -1. So we just bring them here. So we already brought it here. So we need to get now M2. So what do? You multiply both sides by what? 4/what? 4/5, right? So our M2 will now be equals to -1 multiplied by 4/5. And this is equals to what? -4/what? 4/5, right? So -4/5. So that is the gradient for the other line. So that is the gradient for the other line. Now, using the point point slope form, then we know y equals to m x minus x1 plus y1. And we have our point here, x1, y1 as 5 and 3. 5 and 3. So we just do a substitution here. So our y equals to -4/5 x minus 5 plus what? Plus 3. So you can leave it like that, or you can continue. So when you open the brackets, so y equals to -4/5x plus 4 plus 20 all over 5 plus what? Plus 3. And this can be minus 4 all over 5x plus what? Plus 7. Plus 7. Any question up to there?
So for to get the second gradient, you just multiply it by that 5/4 and it switches sides pretty much. Just
Yeah, we know that for the perpendicular, the gradient of the first one times the gradient of the second one should be equals to -1. So you need to look for the gradient of the second so that you can be able to get the solution for the equation of that line to the second one, which is perpendicular to that line. Okay. Yeah, if it is parallel, so you know the gradients are the same. So you use the same gradient. So if it is perpendicular, then yeah, M1 by M2 equals to 1. Any question? Okay. You can do the last example here, and then I give you a quiz. Find the equation of a line perpendicular to -4x plus y equals to -5 that contains point -5 and 1. Find the equation of the line perpendicular to x plus y equals to 5. So how will you solve that? So first of all, you need to transform minus 4x to the equation, the formula of the equation of the line, minus 4x plus y equals to -5. So you need to take the -4 to the other side. So y equals to 4x minus what? -5. -5. Now, since this one is perpendicular, then we know that M1, M2 equals to -1. -1. So we have our M1 here is equals to 4, right? Is equals to 4. So what will be our M2? So we just put back here. So 4 M2 equals to -1. Okay? Equals to -1. So what is the value of M2? So M2, we divide both sides by 4. Is equals to -1/4. So that is our M2. So that is a gradient of the second line. And we have the point. We have the point x1, y1 there as -5 and what? 1. So using y equals to m x minus x1 plus y1, then we just substitute everything here. So when you do the substitution, then we get y equals to -1/4. X minus x1 is -5 plus y1 is 1. y1 is 1. Any question up to there? So finally, our y equals to -1/4 x plus 5 plus 1. So you can leave it like that, or you can continue. So y equals to -1/4 x minus 5/4 plus 1 plus 1. And this is equal to -1/4 x. The LCM there is 4 minus 5 plus 4. What do you get? -1 all over what? 4 minus 1 over 4. And that is the final solution. That is the equation of the line which is perpendicular to the other one. Any question? Are we clear? Yes. Okay. So for the last remaining 20 minutes. So who did not finish with what? Not finish.
I just still have to turn it in. I forgot to submit it.
Yeah, okay. So I had some questions of this one here. Oh, I wrote this one as quiz 2. See, this one should be quiz 3. So you can check one.
Can we write on the quiz?
Yeah, you can just write over there if you have space. Now, space, you can write. You can discuss if you want. So you can look to your neighbor, you can look at your book.